Okay, we're back again. We have a balloon, and right now I'm going to ground it. Most people don't realize that their house is connected to the actual ground, to the actual earth, by grounding straps through the plumbing. Most houses have been hit by lightning, but it goes through all these grounding straps, and it doesn't go through the wood of the house and cause problems. I'm going to ground this. I'm going to get rid of any residual charge that might be on it. Then I will rub it on fur. Okay, so we now have we have a negative side over here, right? Because remember, fur wrapped on any kind of plastic or rubber. And I'm going to turn on the water stream. A nice small stream, so that's not heavy. Doesn't have a lot of mass or a lot of inertia. Now watch what happens when I put this negative side towards it. You can see it down here. We see that it's moving, yes? Right, and little pieces are shooting off. What's happening? We know that as liquids, they're able to move. They're not like solids, right? Which are stuck in their lattice structure. So if these are free to move, then what side of water is positive? The hydrogens or the oxygen?
Oxygen.
It's the hydrogens. Remember the Mickey Mouse, right? Okay, the protons of the hydrogen, right? So they shift positions. So this side is now mostly the oxygens and the hydrogens here, and then we can attract it. Now what if I turn this around and we get nothing? Why do we get nothing on this side? Because this is an insulator. I didn't rub this side. This side has negative charge on it, but as an insulator, it can't race to the other side of the balloon. Does that make sense? So if this side was charged, then this side is still neutral. Okay? So let's go ahead and wipe that off a little bit. Actually, I guess I could have done this just as well. Let me get this nice and charged up. Yeah, charge it up. Okay, go ahead and hold that one right there if you would. Ooh, notice I was already heading towards you. It likes you, Nick.
Ghost.
See, no one thought rabbits were this useful.
They taste good.
Yeah.
Ew.
Worcestershire sauce, you know. Okay, so assuming that these both got charged up well, they should both have, again, charging by the same process. They should both be, do we have a good charge or not? Let's see if we can find a side that's, well, we'll use Nick this time. We'll see if actually, Nick's hair is better than Fluffy. Okay.
That's right.
Okay, let's see what happens. Oh, and
Boom.
there, you see it? They're repelling one another. Again, the electrostatic force is overcoming the force of gravity. Understood? Okay. Let's go back over here again, and we're going to work with the electroscope a little bit more. Okay, remembering on the electroscope, the positives, or sorry, the metal going all the way through, the electrons can move up or down. Okay, we understand what we're doing here? It's kind of like Plinko, they can just go in and out, only they can go up too. All right? So we take our negative charge, we bring it down, the leaves fly out. Right now, this has been charged by contact, and this is being charged by
Transition.
it's shifting. Polarization. It's being polarized. What is the total charge of it right now? Still neutral. They're just shifting sides. Okay? That's the same reason why if I take, remember, I take these little pieces of paper, and if I get a big enough negative charge, I can attract a neutral object because the electrons are shifting places, making one side more positive than the other. Understood? Okay? Likewise, if I take a positive object, meaning it's positive because it gained or lost electrons. Lost electrons, leaving it positive. Using my silk here. So nice. Okay. When no one's in the classroom. Yes. Okay. And notice once again, I'm polarizing the electroscope. Now it's not moving as much, is it? Because remember, a positive charge is much more difficult to produce. So if this is positive, then what do the electrons do? If this is positive, the electrons are attracted, so electrons flow up in the electroscope closer to the glass rod. Do you understand what I'm saying there, yes? Electrons are flowing up, leaving this side. We're struggling with that one, aren't we? No, the whole thing is neutral to begin with.
Yeah.
So if I bring a positive close, what's attracted to a positive?
Negative.
So this side becomes negative, leaving that side
Positive.
positive, and they fly apart. The one thing we haven't shown you yet is called charging by induction. Pause.